I work in the field of genetic change. In a perfect world, you would say guanine would always pair with cytosine and adenine would always pair with thymine. It turns out, however, that sometimes chemicals from the environment can react with our normal nucleotides and change their coding characteristics so that mistakes are made when polymerases try to read them. These are mutations, and mutations cause genetic diseases. My role in the field of toxicology is as a person who's both a biologist and a chemist who studies how chemical damage to our informational molecules is converted into changes in coding that results in genetic change. I'll emphasize, of course, this is the basis for all genetic disease, but it's also the basis for evolution. In other words, mutations happen naturally. That means that we don't all look alike. And that means there's diversity in a population, and that's because of mutations. And evolution is a really good thing, because if we were all alike when the environment changed, then the chance of extinction might be very high. If there's diversity in a population, that's actually a hedge that life uses in order to be able to make sure something's going to survive, because some members in the population, where they may be considered quote-unquote weaker in the initial environment, when the environment changes, they're the ones, for example, with hair on them and survive the global winter that happens after the meteor strikes. So we're interested in chemical modification of DNA and RNA as it relates to the causation of disease, but we're also interested in the rates at which genetic change happens in a population and how that's a good thing and that it provides for the continuance of life.